All right, this is our last one of these. This is learning target 9E. Solve one variable inequalities, including quadratic inequalities, and express the answer algebraically and on a number line. Right. So here we have 3x squared plus 7x minus 6 is greater than or equal to 0. Okay. The way we are going to solve this is we are going to treat this like an equation. Right? First thing we're going to do is we're going to solve this quadratic equation. So 3x squared plus 7x minus 6 is equal to 0. Right? We have three ways to solve a quadratic equation: factor it, complete the square or quadratic formula. I'm going to try to factor it first, so that's box diamond. So I'm going to do 3x squared minus 6 gets me negative 18x squared. Looking for factors of negative 18x squared that add up to 7x. So it's going to be 9x and minus 2x. So I can figure out my factors here. So my factors are 3x minus 2 and x plus 3. I'm going to set each one of those equal to 0 using the zero product property. First one I have is x is equal to 2/3. Find my other 0, x is equal to negative 3. Okay, so these are my boundary points. I'm going to use these as my boundary points, right? So what that means is I am going to draw a number line. Just use this as my number line. And I am going to drop my 2 points on there. This is going to be negative 3. This is going to be 2/3. Okay, and I can go back to my original inequality to choose what symbol I am going to put on my boundary points. Are these boundary points included in the solution? Yes, they are included. How do we know that? We look at that symbol. If it is greater than or equal to, or less than or equal to, that's going to be a closed circle. And if they were like this, that would be an open circle. Okay, so now that I've got these boundary points in here, I'm going to choose a point in each region. So it cuts it up into 1, 2, 3 regions. I'm going to choose a point in each region to test, right? So I am maybe going to choose the point between here is 0. That makes it nice and easy. I need to choose a point over here. I'm going to choose 1 because that's going to be nice and easy. I'm going to choose a point in this area, I don't know, negative 10. And I'm going to test these 3 points to see if they are true or false, to see if they are part of the solution or not. Okay. When I say test, I've already picked the values I want to test. What am I going to plug those into? I'm going to plug them into this original inequality up here at the top. So let's test if x is equal to negative 10. So if I plug in negative 10, I'm going to have 3 times negative 10 squared plus 7 times negative 10 minus 6. Is that greater than or equal to 0? So doing some math here, 300 minus 70 greater than or equal to, yeah, I can tell already that's going to be true. Right? So that means I'm going to shade in any part that makes it true. So anything over in this region is going to make it true. Next, I'm going to test if x is equal to 0. Does that make it true? So I'm going to have 0 plus 0 minus 6. Is that greater than or equal to 0? Nope, that's going to be false. So I don't shade that in. Right, so this region, everything in there is going to make it false, so I'm not going to shade that in. I have one more point to test. I'm going to test it. X is equal to 1. So that's 3 times 1 squared plus 7 minus 6. Is that greater than or equal to 0? Let's see, this is 9 plus 7 minus 6. Oh, yeah, this is also going to be true. That means everything over there is going to be true, so I can shade that in. So now I've got it on a number line, I also need to express this answer algebraically, right? So in order to do that, I could do x. I need to write two inequalities, one that represents this and then one that represents this. So let's just look at this. All of the x's will be less than or equal to negative 3. So the x's are less than or equal to negative 3. How do I write an expression for this side? Well, all of my x's are greater than or equal to negative 2. Or did I say negative 2? I meant 2/3. 2/3. So it could look something like that.